Hello dear students, today I will discuss about some comparison test. We have already studied about comparison test. So for finding the nature, for determining the nature of a positive term series. Positive term series means we know just we are trying to understand what is the nature of the series. Suppose this is positive term series. Then for determining its nature as whether it is convergent or divergent or okay. So just we have to compare this series with another series summation Vn. If Vn is helping series, if Vn is known to be non-convergent and there is a condition given by Vn tending to what? Finite and non-zero, then we say that if Vn converges, then Un converges, Vn divergence, then Un divergence. This was the what? Comparison test. Now one by one we are trying to understand different type of tests. Okay, for determining the convergence and divergence of a given positive term series. Positive term series means we know all the terms are positive after some particular terms from the starting. Okay, so here next test is ratio test. So ratio test, we also know some basic properties of series, of infinite series, and basic tests just like geometry series, P series tests, integral tests, we know. Here D'Alembert's ratio test. Okay, known as ratio test. Generally, just forthcoming all the tests will depend on this ratio of nth term of series, nth term and n plus 1 term. So in this ratio test, just we have to know what is the statement of different tests. So here D'Alembert ratio test. Now clear? So it's a statement because a statement is main thing for applying the test. So if summation Un is positive term series, then summation Un is a positive term series, then positive term series such that limit of Un plus 1 upon Un n tending to infinity. Means we are finding ratio n plus 1. Just first of all find from the series nth term of the series and just find n plus 1, and this is divided by this. This is a ratio. Just we are trying to find the limit of this ratio. Okay, such that limit n tending to infinity Un plus 1 by Un equals to k. If summation un is positive term series such that limit is this equals to k, then what is the statement for this test? Then series un is convergent for k is less than 1. Means its limit is k, the value is less than 1, then convergent. And series un is divergent for k greater than 1. If this is ratio and its limit is k is less than 1 convergent, greater than 1 divergent, and if, or we can say and, for k equals to 1, the test fails to decide the convergence or divergence of series. Means if limit is equals to 1, for k equal to 1, the test fails to decide the convergence or divergence of series. So this is a statement of D'Alembert ratio test. It can be proved by using comparison of ratio. Okay, so proof is not so much important here, just for testing convergence, divergence of a particular series. Just we will use this statement according to D'Alembert's ratio test. What? Just find un, then un plus 1, and find this ratio and find its limit. If limit is less than 1, convergent, greater than 1, divergent. If limit is equals to 1, because k, this is limit, so k equals to 1, then test fail. Then we cannot use this test for testing convergence or divergence of the given series if this limit is equals to 1. Because in this case, maybe series convergent or divergent, but this test will not able to decide whether convergence or divergence of the given series. Okay. If limit less than 1, then convergent, greater than, then divergent. It's convenient form because at the starting just you will get this type of statement. Okay. Because just comparison of ratio, whenever we compare one series with another series and their ratios are comparing, and then we know that if un plus 1, summation un is series and summation vn is series, another series, and we know that this series is convergent divergence by easily by any of the basic test, and then if Vn is convergent and un upon un plus 1 and Vn plus 1 upon Vn plus 1, Vn. This is ratio for this series, this is ratio for this series. In this case, if this less than, then we can prove it. What? If Vn convergent, then un convergent, if this condition is true. If here greater than and Vn is divergent, then this series is divergent. This is helping series because its convergence divergence can be found easily by basic test. So if this is convergent and we are having this type of ratio, comparison of ratio, its ratio, compare. this ratio is less than this ratio, and this is non-series, and if this is convergent, then this condition will give convergence of this. If this is divergent and if this condition is satisfied, then as this divergent, it will be divergent. We can see. So this is comparison of ratio. By using this ratio, we can prove this test, also further test. So this comparison of ratio is also important to know, because by using this comparison of ratio, we are testing, we are using proving ratio test, reverse test, logarithmic test can be proved. Okay. So here main statement of ratio test is this. Okay. So here ratio we find n plus 1 is the numerator and n is denominator. So it's a higher test. For the writing of higher test, just reverse test, logarithmic test, we are using ratio just like in reverse order. Means if we take, because this is original statement, it can be proved by using comparison of ratio, it can be proved. Now, suppose we are taking ratio, that is convenient form, it is convenient form. Just take here what? Un. Here un plus 1, just in reverse order, in the inverse of this. Then a statement will change. Un upon un plus 1. Limit is this. Suppose. Then series is convergent for k greater than 1. That limit is greater than 1. Convergent for this type of ratio. Because there are two type of writing ratio. Un plus 1 upon this. Also you can find un upon un plus 1 this. From here it is clear that first statement was in this form. So less than 1 convergent. But if we take this, then greater than 1 convergent. So if we take like this un upon un plus 1, then for convergency k greater than 1, for divergency k less than 1 and equal 1, test fail. Then we will use further test. Okay, so here just ratio test. When ratio test fails, if ratio test fails, that is limit n tending to infinity un upon un plus 1 equals to 1, then we use following test. First, Raabe's test. Okay, Raabe's test, that is RAABE, Raabe's test. We know if ratio test fails, that is when fail ratio test, limit is equals to 1. Then we use following test for further test. Raabe's test. Here we find limit n tending to infinity just at the time of ratio test. We have already got the value of un by un plus 1 and limit is 1. So just use this value that is un upon un plus 1 already found out at the time of applying ratio test. Subtract minus 1 and multiply n, and this is greater than 1 implies is convergent, less than 1 divergent, equal 1 test fail. This is very simple process. Remember this. Whenever ratio test fails when its limit is 1. And then we use either Raabe test or logarithmic test, Gauss test, De Morgan-Bertrand test. Okay, further test. So here, if ratio test fails, then we can use any of the previous method, a basic test, P series test, geometric series test, integral test, any of the test we can use, whichever is very suitable for the value of un. So here, just for using further test, that is Raabe's test, just we see that if in this case the value of un upon un plus 1, if there are function like rational functions and some polynomial upon some polynomial, same degree of polynomial, that is n square, second degree, first degree, third degree polynomial, just having rational functions, then we can subtract 1, then taking LCM can solve, higher terms will vanish, and then we can multiply that, and first term, if first term, we can get first term as without n and further terms in terms of n. When we try to use Raabe's test, if un upon un plus 1 is a rational function, just like polynomial upon polynomial, just subtract minus 1 and then taking LCM solve it and then multiply to by n, and after multiplication if we get first term, if it can be expanded as a series and a finite series or infinite series, and first term will free from n and further term having n in denominators, then we can use Raabe's test, because for finding limit we can get first term as a limit and we can compare like this. If limit is greater than 1, convergent, less than 1, divergent, equal 1, test fail. Clear? Raabe's test. And if un upon un plus 1, when ratio test fails, un upon un plus 1 is a value which are having some power, that is some thing upon, just like suppose the value of un upon un plus 1 having what? Some power quantity. Numerator upon denominator also power quantity is there generally. Then we can, log is used for simplifying the power, so exponent, so we can take log both sides and it can be simplified. If it can be simplified in such a way that if this can be expanded as a series and first term having 1 upon n, second, third, fourth and further term are having denominator as n, not numerator, then we can multiply it by n, here also by n, so first term will free from what? N. Okay, free from n. So we can use logarithmic test whenever the un upon un plus 1 having power quantity as a power term. Then just we taking logarithmic on both sides and multiply by n. If we get a series, first term is free from n and further term having denominator contains n and power of n's. Then we can find the limit as a first term and we can compare just like this. So logarithmic test is what? This is Raabe's test statement. Now logarithmic test statement is what? Logarithmic test is just like this. Here this Raabe's test and also we use what? Logarithmic test. Logarithmic test. In the case of logarithmic test, just here we are taking logarithmic of un upon un plus 1. Remaining statement same. Just take its log and multiply it by n, and this tending to quantity greater than 1, that is its limit, is greater than 1, convergent, less than 1, divergent, equal, test again fail. When the test fails, just we are trying to use another test. Further test also available, Gauss test and etc. So here we are using logarithmic test and Raabe's test. If ratio test is fails, logarithmic when un upon un plus 1 having power exponent, and if un upon n plus 1 having rational function polynomial upon polynomial, then we can use Raabe's test. Also, if un is in such that we can use basic test, then we can also use, because at limit equals to 1 ratio test fails, so you can use any of the test, and generally we are trying to use Raabe's test, logarithmic test. Okay, so take some questions for this test. So here further test is what? Gauss test. Now we are trying to solve some questions related to higher ratio test and also ratio test. Okay, so first of all, take question first, that is what? Test the convergence of the series so here what? This is the given series. Okay, so solution. Here we have un equals to, we have series un where un equals to, just see the series un equals to what you can write. For testing of a series, just you have to find first nth term. Okay, so here what? Series 1 upon 2 root 1 x square x4 x6 power means 0 2 4 6, that means x to the power 2n minus 2 we can write, because n equals to 1, then x to the power 0 1, and denominator having just what? 2 root 1 3 root 2 4 root 3, that means what? n plus 1 root n. This can be the nth term of the given series. Okay, so here in this series we see that nth term also include x. So convergence or divergence of this series will depend on the value of x. Okay, so just here see that root or power and x to the power. So we can use ratio test. So first of all, for testing, we have to find un. Then here un equal to this. This implies also un plus 1 equals to what? Just in place of n. In place of n plus 1. So here 2n plus 1 means 2n plus 2 minus 2, so 2n. X to the power 2n upon here n plus 2. N plus 1 plus 1, 2 root over n plus 1. So this is un plus 1. For ratio test, we are finding what? Un plus 1 upon un, just un upon un plus 1. The convenient form we will use. We see that un upon un plus 1 ratio. We have to find un upon un plus 1. Un means this. So x to the power 2n minus 2 upon n plus 1 root over n. Un divided by un plus 1. So divide this divided by this. X to the power 2n upon n plus 2 root over n plus 1. Now you can simplify it. X to the power 2n into x to the power minus 2 upon n plus 1 root over n into divide into, then just inverse it, n plus 2 root over n plus 1 upon x to the power 2n. Now what? X to the power 2n, x to the power 2n cancel, and here n plus 2 upon n plus 1. These two quantity with 1 plus and root over n plus 1 upon n. 1 upon x square. We are getting this like. Now our target is what? Finding its limit. Okay. So here this can be written as, by taking n common, what? 1 plus 2 by n, 1 plus 1 by n. Here also 1 by 2 power 1 plus 1 by n. Okay. This n common, n cancel, this 1 upon x square. So it is clear that its limit will be what? 1 by x square. This tending to means what? Its limit. Okay. So its limit is equals to, after this line you can write like this also. So this tending to what? 1 upon x square as n tending to infinity. We can write its limit is equals to 1 by x square as n tending to infinity, because this is 0, this is 0, this is 0. So its limit is 1 by x square, because 0, 1, 1. Okay. Now here its limit after this line, just write like this, limit n tending to infinity, un upon un plus 1 equals to 1 upon x square. According to ratio test, the series is convergent for 1 by x square is greater than 1. Because we know that un by un plus 1 limit, that is, this is what, k. So it is greater than 1, then convergent. So according to ratio test, the series what is, according to ratio test, the series this is convergent for x square is 1 by x square. This is this limit is greater than 1. That is x square less than 1. It will depend on the value of x, and this is divergent for 1 by x square is less than 1. That is x square greater than 1. So just we are deciding here what, x square is less than 1, then convergent, x square is greater than 1, then divergent. Now x square may be equals to 1. Here x square may be equals to what? 1. Okay? And for x square is equal 1, ratio test fail. Because according to ratio test, its limit, we are comparing with this limit. If limit is greater than 1, that is, this is greater than 1, convergent. 1 by x square greater than 1 means x square is less than 1, convergent. X square greater than 1, divergent. And if x square equals to 1, that is, this is equals to 1, limit will be 1. Limit will be 1. If for x square equal to 1, ratio test fail. And now x square may be greater than 1, may be less than 1, or may be equals to 1. For deciding at x square equals to 1, we can use any of the basic test, just like comparison test. So here our next work is what? Testing for convergence and divergence at point x square equal to 1. Now, for x square equals to 1, we have un equals to, not here, not just, we are not using Raabe's test, because just this is not like rational function, polynomial by polynomial, because root is there and also n plus 2 is in the denominator. So we are using any of the basic test. Comparison test we can use, because we know that for comparison test we are finding helping series Vn from un. If un can be expressed as a what? Series of 1 by n. So here un equals to this, x square equals to 1, un upon un plus just un equals to this, x square equals to 1. So here we see that 2n minus 2, that means x square power n minus 1. So x square equals to 1, that is 1. So un equals to what? 1 upon n plus 1 root n. Now here we see that if, because for comparison test we are finding Vn from un generally. So here un equals to this, and when un can be expressed as a series in power of 1 by n, so here 1 by n we can express it just like this. Suppose n taken common, then n to the power 1 by 2 is this. Here n is common, 1 plus 1 by n. Just this is n common, 1 plus 1 by n. Now this is equals to what? 1 upon n to the power 3 by 2, just 1 upon 1 plus 1 by n, because it can be taken in numerator 1 plus something power minus 1, and it can be expressed as a series. The first term will be 1, and if this term is not, can be neglected, because for comparison test we are taking un by vn for testing the condition. So here we can take vn equals to and 1 by n to the power 3 by 2. We have un equal to this. So let vn equals to 1 upon n to the power 3 by 2. Then just we are trying to testing series for x is equal to 1. Let vn equal to this, then limit n tending to infinity un upon vn equals to un this and vn this. So this divided by this, what? This will be cancelled and we get 1 upon limit n tending to infinity 1 upon 1 plus 1 by n. 1 upon, because 1 upon n to the power 3 by 2, 1 upon n to the power 3 by 2. Un divided by vn, this will be cancelled, so just we get like this. And now n tending to infinity 0, 1, 1 by 1, 1. Non-zero number, finite. This is the condition for comparison test. So this, then this, so we can apply comparison test for summation un and summation vn, because this is the condition for comparison test. If this condition is satisfied, then summation un and vn, for summation un and vn we can apply comparison test. And according to comparison test, summation un is convergent. As summation vn is, that is summation 1 upon n to the power 3 by 2 is convergent. Here P is equals to 3 by 2 is greater than 1. P series test. Clear? Because summation Vn, summation 1 upon n to the power p, p equal to 3 by 2, p equal to 3 by 2, that is greater than 1, p greater than 1, then 1 by n to the power p, p series is convergent, p greater than 1 convergent. So Vn is convergent, so Un is also convergent. Because according to comparison test, summation Un and summation Vn will be a same. Both together convergence or divergence. So here summation Vn is convergent, that is summation Un is convergent. So here we get series is convergent also for x square equal to 1. So final decision is what? The given series is convergent for x square is less than and equal. Finally, we get given series summation Un is convergent for x square is less than equal 1. Because for less x square is less than 1 convergent, also for equal 1 is convergent, and divergent for x square is greater. Okay, divergence x square greater than 1, converges x square is less than equal 1. Clear? So this is ratio test. For a given series, just you have to find first Un, then Un plus 1, and ratio Un by Un plus 1, find, and its limit. If limit is less than 1, greater than 1 convergent, less than 1 divergent, equal 1 fail. If fail, then you can use any of the basic test or further test. But here, just we will use what? Comparison test. Okay. So finally, because series having x, so the convergence or divergence will depend on the value of x. So if x square less than equal 1, x square may be equal 1, less than 1, greater than 1. So x square is less than equal 1, convergent, greater than 1, divergent. So this is the final decision. Okay, now take second question. Just here see that in this question just we will use in the case of when ratio test will fail, we will try to use either of the Raabe test or logarithmic test. So here given series is, just see the given series is what? Test for the convergence of the series. Here we have series summation Un where Un equals to 4 into 7 into 3n plus 1, just like this, 1 to 3n, 1 to n, x to the power what? N, x to the power n. This is given series. Another term is given here. So n equals to 1, here n equals to 1. So what? 4 by 1, 4 by 1 x. That is what? 4x by 1 plus, if n equals to 2, that means first value will be 4, second value 4 into 7 x to the power 2 upon 1 into 2, third 4 7 10 upon x cube upon 1 2 into 3. This is series. So nth term is this. The series can be written also like this. Summation un equals to this. This is the series. So just you have to write what? Here already given un equal to this. So in this case, whenever we are having un as a rational function, numerator and denominator having product of some terms, so you can use ratio test. So un equal to this, then un plus 1 equals to, just write we see that write the ratio direct un upon un plus 1, because we are trying to find the value of ratio and then its limit according to ratio test. So un upon un plus 1, in this case this multiplication are there. So un means this 4 into 7 into up to 3n plus 1 into x to the power n upon 1 into 2 into 3 into up to n. Division here into, that means just write un plus 1 in inverse order. So un plus 1 means here n plus 1, n plus 1, n plus 1, n plus 1, and in reverse order, inverse form. So this will be 1, 2, 3 up to 3n plus 1. No. n, and then n plus 1. Just numerator, denominator will go to numerator as division, and this will be come to denominator and up to 3n plus 1 and what? 3n plus 4. 3n plus 4, because just 3 plus and add 3 plus 1 plus 3, 4 and x to the power n plus 1, n plus 1. Okay, so we get what? 1 to n cancel out, n plus 1. Here 4 to 3n plus 1, 4 to 3n plus 1 cancel out. So 3n plus 4. So we get n plus 1 upon 3n plus 4. X to the power n, x to the power n cancel. 1x will be there. 1 by x. Clear? So this. So its limit, we can find its limit, very simple. Un upon un plus 1. So limit n tending to infinity, un upon un plus 1 equals to limit n tending to infinity. It can be written as by taking n common, 1 plus 1 by n common 3 plus 1 by 4 by n cancel. So we can write like this: 1 plus 1 by n upon 3 plus 4 by n into 1 by x. So what will be the limit? N tending to infinity, 0, 0, 1 by 3 x. So 1 by 3 x. So its limit is equals to 1 by 3x. Now according to ratio test, if this limit is greater than 1, because un is here, so greater than 1 convergent, less than 1 divergent, equal 1 test fail. According to what? Ratio test. Okay. So here just see what will be the case for limit equal to 1. Clear? apply ratio test applying ratio test we get series UN is convergent for 1 upon 3x is greater than 1. Its limit is 1 by 3x. So ratio test, if this limit is greater than 1, convergent, greater than 1 convergent. That is, here we can write x less than 1 by 3. X less than 1 by 3. And divergent for 1 by 3x is less than 1. That is, x greater than 1 by 3. And test fail if for x equals to 1 by 3x equals to 1. That is, x equals to 1 by 3. So x may be equal 1 by 3, greater than 1 by 3, less than 1 by 3. Greater than 1 by 3, divergent. Less than 1 by 3, convergent. Test fail when x equal to 1 by 3. Okay, x equal to 1 by 3. Because x equal to 1 by 3, that is limit will be 1. So test fail because its limits will be 1. So in this case, just see here, the value of Raabe's test can be used. We know Raabe's test, un upon n plus 1 minus 1 into n. If un upon n plus 1 can be written as a series having in 1 by n, then we can multiply. So here, for deciding x equal to 1 by 3, for x equal to 1 by 3, test fail. So for deciding for x equal to 1 by 3, we see that what? Un upon n plus 1 equals to, just we are getting what value there? 1 upon n plus 1 upon 3n plus 4. This was the un because x equal to 1 by 3, because 1 by 3x, 1 upon x, so x equals, just or see our previous value, what? Un upon un plus 1 was what? 1 upon 1 plus n upon 3 plus 1 upon 1 plus 4 upon n into 1 upon 3x. Just in the previous part, what? Un upon n plus 1 equals to 1 plus 1 by n upon 1 plus 4 by n, 1 upon 3x. For x equals to 1 by 3, x equals to 1 by 3. So 1, 1, this is 1. So we get only this term, un upon n plus 1. So for x equal to 1 by 3, we see that un upon un plus 1 is equals to what? 1 plus 1 by n upon 1 plus 4 by n. This, and this can be written as what? 1 plus 1 by n numerator into 1 plus 4 by n inverse. Just it can be taken in the numerator as an inverse. Just we know the formula. Just see here. 1 plus x inverse equals to what? 1 minus x plus x square minus x cube plus and so on. Binomial theorem. 1 plus x power minus 1 equals to what? X to the power 0, x to the power 1, x to the power 2, x to the power 3 and so on. Just here minus, so plus minus plus minus plus plus. So this will be the expansion for this. So here we can expand this. What? 1 plus 1 by n and expand this by using this. So first term 1 minus second term minus x 4 by 3 minus 4 by n plus x square plus 4 square by n square minus 4 cube by n cube and so on. This will be the expansion. Now after multiplication we can get what? After multiplication, just see first few terms. After multiplication, just we can get some of the terms here. What? 4 by 3n is there. So 4 by 3n. 4 by 3n. Because we are taking common 3. There's a 3 common, then 4 by 3n. Yes, 4 by 3n. So here, just multiply it 4 by 3n. 4 by 3n square. 3n cube. Just like this. So just multiply it 1. So 1 and 1 into this minus 4 by 3n and 1 by n into this plus 1 by n. That is 1 by n. So just you have to multiply and write 2 or 3 terms only. So 1 by n minus 4 by 3n. So here what? 3n. So 3 minus 4 minus 1 by 3. So minus 1 by 3n and for that term you can write plus 4 by 9s n square plus 4 by 9 n square and like this. This will be the series form. Just un by un plus 1 is expressed as a series form having 1 by n terms, means denominator will contain n. Here 1 is first term is 1. So for reverse test we know this minus 1 into n. So this minus 1 means 1 cancel out and n to n means n first term will have only minus 1 by 3. So here we are getting un upon un plus 1. So implies n into un upon un plus 1 minus 1 equals to minus 1 by 3 plus 4 by 9n. One subtract from both sides, so 1 cancel. Then multiply n. Multiply n means n square and so on. 1 n common. This n and this n will cancel out. Okay, so first term will be minus 1 by 3. Second term 4 by 9n. And further terms will contain n in denominator. So we can find its limit and tending to infinity. Here limit at tending to infinity, that is all terms will be 0. Just limit will be minus 1 by 3. So here for x equal to 1 by 3, we see that after this line, limit n tending to infinity n into un upon un plus 1 minus 1 is equals to what? Minus 1 by 3. Its limit is minus 1 by 3. Or this is less than 1. Was negative value less than 1. And un is in the upper side. So less than 1 means divergent. So by applying Raabe's test, because this combination for Raabe's test, so by applying Raabe's test, we get what? Less than 1 means divergent. We get summation un is divergent for x equals to 1 by 3. Raabe's test, because limit is less than 1, so divergent. We get series is divergent for x equals to 1 by 3. So x equal to 1 by 3 divergent, x equal to greater than 3 also divergent. So greater than equal 3 divergent, less than convergent. So finally we get the given series is convergent, given series un is convergent for x is less than 1 by 3 and divergent for x is greater than 1 by 3, because equal, divergent, greater than, divergent, less than, convergent. So this is our final decision. Okay, so series is diverges for x greater than equal 3 and converges for less than 3 by using Raabe's test. So once ratio test fail, then just we use Raabe's test for the particular point x equal to 1 by 3. So at this point divergent, so divergent for x greater than equal 3 and convergent for x less than 3. So when ratio test fails, then you can use Raabe's test. Here, because this value can be expressed as a series in terms of powers of 1 by n, and first term was 1, so we can use this Raabe's test. Okay. So here for logarithmic test we can use also the case when ratio test fails, we can use logarithmic test. Just see in this example questions. Question is discuss the convergence of the series. Okay, so here what is given? X 2 square x square. Here series is, just see, x plus x square n square upon 2 factorial. X square to 2 square x square upon 2 factorial. Two square x square 3 cube x cube upon 3 factorial plus and so on. This is the given series. Okay. 3q x cube 3 factorial and so on. This is given series. Summation given. Okay. So this term will be what? 4 power 4 x power 4 upon 4 factorial. This is series. Given series. Okay. 4 factorial, 4 power 4 x power 4 and so on. For this series, we can write, because here power is main thing, just like you can see. Here, un is what? It's n power n x power n upon n factorial. If we take n equals to 1, then 1 x upon 1 x. 2, then 2, 2, 2, 2. 2, 2, 2, 2. 3, then 3, 4, then 4. This is even. Implies un plus 1 equals to what? N plus 1 power n plus 1. X power n plus 1 upon n plus 1 factorial. Clear? So, just try to ratio test. We see that un upon un plus 1, un upon un plus 1, this ratio is equal to un means this, n to the power n x to the power n upon n factorial into divided by this means n plus 1 factorial upon n plus 1 to the power n plus 1 x to the power n plus 1. So here we see that n factorial, n plus 1 factorial. So n plus 1 into n factorial cancel. So n plus 1 upon, here n plus 1 power n plus 1 power 1 means 1 n plus 1 and this one n plus 1 will be cancelled. So n factorial cancel, n plus 1 cancel, so n plus 1 power n power n. So n upon n plus 1 power n, we can write just like this. N upon n plus 1 power n, this upon n plus 1 power n. N plus 1 cancel and this cancel. X to the power n cancel into 1 by x. So its limit will be what? Un upon un plus 1. So limit n tending to infinity, un upon un plus 1 equals to limit n tending to infinity. Here see n upon n. So n taking n common, n cancel, 1 plus 1 by n, 1 power n. So here we can write like this, 1 upon 1 plus 1 by n power n. One power n cancel, 1 plus 1 by n power n and 1 power n 1 into 1 by x. And we know that limit n tending to infinity 1 plus 1 by n power n e. So 1 by ex. So this is equals to 1 upon ex. 1 upon ex. Okay. So its limit is equals to this. Now by ratio test. By ratio test, series will be convergent if limit is greater than 1, if less than 1, divergent, if equal 1, test fail. So here we can use after this line. Now applying ratio test, we get the series summation un is convergent for is greater than 1. Its limit 1 upon e to the power x. If this is greater than 1, then convergent ratio test. That is here. That is x less than 1 by e. X less than 1 by e. And divergent for 1 by ex is less than 1. That is x is greater than 1 by e. X is greater than 1 by e, then divergent. And test fail for x equals to 1 by e equal 1 by x. So x equals to 1 by e, test fail. In this case, in the fail case, just we can write what? Here see, the value of un upon un plus 1 is equals to we are getting what? Un equals to for x equals to 1 by e. See, for x equal to 1 by e, test fail. Now for x equals to 1 by e, un upon, we see that un upon un plus 1. Just we are getting in the previous section what? Value 1 upon 1 plus 1 by n power n into 1 by x. Un upon just in the previous section un upon un plus 1, 1 upon 1 plus 1 by n to the power n, 1 by x. So here x equals to what? 1 by e. So 1 by e means e by this. So un upon un plus 1 for x equals to 1 by e. X equals to 1 by e. So e upon 1 plus 1 upon n power n. So here see that the value of un upon un plus 1, un upon un plus 1 equals to e upon this power n. Okay, this power n. So here we can express this also in terms of not always we can get the value term by term having n in denominator, because some n will be in also in numerator. So just here we cannot use Raabe's test, because for Raabe's test series expression should be like denominator having n only, but here both having. So we can use logarithmic also, because this power something e log e 1. So take log on both sides. So logarithmic of un upon un plus 1. Let's take log on both sides. So we get what? Log of e minus for x equal to 1 by e, we see that this, taking logarithmic on both sides, log of this is equals to log of a by log of b. Log of a by b means log a minus log b. So log e minus log b means what? Log 1 plus 1 by n or n. So log e means 1. So this is equals to 1 minus, here n will be come in front side 1 by n. Now we know that log 1 plus x is equals to what? X minus x square by 2 plus x cube by 3 minus and so on. This is logarithmic series. This is logarithmic series. It can be used here. It can be used here. Okay. So using this we can write 1 minus n of what? This log 1 plus x equal to x means 1 by n. 1 by n minus 1 by 2 n square plus 1 by 3 n cube minus and so on. X square by 2, x cube by 3, x square by 2, x cube by 3 and so on. So here we get n into n, 1 cancel. Now minus plus 1 by 2n, 1 by 2n minus n cancel, 1 by 3 n square and plus and so on. We get like this. Okay, so what is this? Log of un upon un plus 1. Clear? So we are getting this. Now for logarithmic test, also multiply this to by n. Multiply this to by n. So we get what? After this line, n log of un upon un plus 1. Just multiply by n. So if here n is in denominator. Okay, just all term having denominator as n. Okay, now multiply by n. Here n, 1 n cancel out. So half minus 1 by 3n plus and so on. All term having n after half. So its limit will be what? Half. So here we can write limit n tending to infinity n of log of un upon un plus 1 limit n tending to infinity, limit of this here half, because n tending to infinity. So this is half and n tending to infinity is 0, here 0, 0, 0 and so on. So limit is half. This is what? Less than 1. Less than 1. Un is numerator. So less than 1 means divergent. Implies using logarithmic test. Logarithmic test. Because we know that logarithmic test means just find out limit of this. If limit is greater than 1, convergent, less than 1, divergent, equal 1, then test fail. So here less than 1, so divergent. Using logarithmic test, the series is logarithmic test. This is series is divergent for x equals to 1 by e. Because for x equals to 1 by e, we are using this. So by using logarithmic test, summation un is divergent for x equal to 1 by e. So our final result will be x less than 1 by e, convergent, divergent, greater than and equal. So finally, given series is convergent for x is less than 1 by e and divergent for x is greater than and equal 1 by e. So for all values of x, just we are deciding when convergent, when divergent. Here, just we will use what? Logarithmic test. We have used logarithmic test. Okay. So this is the technique for finding the nature of series as convergent or divergent, for finding nature of the series as a convergent or divergent by using ratio test. Ratio test means that we are trying to find this ratio for a series, and first apply ratio test, and then if ratio test fail, that is limit 1, use any other test, or you can further test Raabe's test, logarithmic test. By using that, we can determine the nature of given series as convergent or divergent for some values of x. Okay. Now second test, that is Gauss test. Just in the further process, after the test of Raabe's test, logarithmic test, whenever we start from ratio test for testing of convergence and divergence of series, so in this sequence there are many tests. So just 3 remaining tests are there. Now we have to discuss one by one in short, and one of the questions will be solved by that test. So next test is Gauss test. Okay. Gauss test. So in this test, if we can write the statement, what is the statement? If for positive term series, if for positive term series we can have un upon un plus 1 equals to, if for this positive term series we can have like this relation alpha plus beta upon n plus gamma upon n square, where alpha greater than 0. Okay, or alpha greater than 0, if we can have, means for a given series, if we can write like this, in this form, where alpha is a number greater than 0, beta, gamma, n square. Just here we see that n is in denominator. Okay, if we can have like this, then the statement of this test, Gauss test, then first decision, second decision, the C. If un upon un plus 1 can be written in this form, here alpha, beta, gamma are free from n, and here alpha is greater than 0. If, just we can write in this format also, then summation un is series is convergent for alpha is greater than 1, alpha is greater than 1, and alpha is less than 1, divergent, and divergent for alpha is less than 1, whatever beta and gamma may be. Means beta gamma may be any value. If alpha greater than 1, then series will converge. Gent. Alpha greater than 1. Alpha greater than 0. And then alpha greater than 1, then this series will be convergent. Alpha less than 1, this alpha is less than. If we can write like this format, then alpha greater than 1, convergent series, alpha less than 1, divergent series, and alpha must be greater than 0. This is this alpha less than 1, divergent. Okay, less than divergent. And second, this is convergent for alpha equals to 1 and beta is greater than 1. Gamma may be any value. Okay. Here alpha must be greater than 0. That is alpha positive. Clear? This is 0. Suppose this is 0. Alpha positive, this is 1. So alpha is less than, convergent, greater than, divergent. If alpha equals to 1, then we see beta. If it is 1, then we see beta. Beta greater than 1. Beta greater than 1, then convergent. And divergent for alpha equals to 1 and beta less than equal to 1. Beta is a number. Beta greater than 1, then convergent. Beta less than equal 1, then divergent. But alpha should be equals to 1. So this is statement for Gauss test. Okay. Whenever reverse test fail, just like ratio test fail, reverse test fail, then you can apply Gauss test. Try for Gauss test. For convergence and divergence, for taking the decision whether series is convergent or divergence, just you can use this statement. So here very simple. Just remember this format. If we can write this un by un plus 1 as in this format. Here alpha plus beta by n plus gamma by n square, alpha is greater than 0. So gamma may be any series, may be any value. If n square. Here alpha beta are free from n, and gamma will contain in denominator n. Okay. So in this format, if these conditions are satisfied where alpha greater than 0, then this is the statement. Using this test, Gauss test, we can solve question also. Clear? And take a question for this test. So see the question. Okay. Test the convergence of the series solution. Here just see here, just see the series in the given questions. 2, 4, 2 square, 4 square, and then 2 square, 4 square, 6 square, and then and etc. Okay, in this format, just given value 2, 4, 2, 4, 6, 2, 4, 6, 8. And in numerator 1, 3, 1, 3, 5, 1, 3, 5, 7 and so on. Okay, 1, just 2, 4, 2, 4, 6 and 3, 5, just 3, 5. 3, 5 and 3, 5, 7. Okay, and 3, 5, 7, 9. Just this. So UN can be written like what? 2, 4, 6. So 2, 4, 6 means what? 2, 4, 6. So you can write 2 square, 4 square, 6 square up to first value 2 and 4. So 2 square and 4 square. So we are writing what value? 2n plus 2 square. 2n plus 2 square. Clear? And 3, 5. 3 square, 5 square, 7 square. So how many? What can be written here? 2 n plus 1 square. Okay, 2n plus 1 square, I think. 2n plus 3 square. Sorry, 3 square. Here, just see, if we put n equals to 1, n equals to 1, then we are getting 2 square. For n equals to 0, suppose n equals to 0, if n equals to 0, then 2 square, 3 square. If n equals to 1, 4 square, 5 square. So 2 square, 4 square, 3 square, 5 square. It is a start from n equals to 0, because we can give the index value as n equals to 0, 1, 2, 3, 4 also for counting. So we can write un equals to this for the given series. N equals to 0 means just we are getting 2 square y, 2 terms 0, 1, 1, 2. 1, 2 means 1, 2 means just here n equals to 0, 2 square and 1, 4 square. So see the given series 2, 3 and then 4, 2 terms and then 3 terms and then 4 terms. So we can write what? Un equals to this. Clear? Here un equals to this. So un plus 1. What? Un plus 1? In the given series, we can write another term like this. Clear? So here the series is given so n plus 1, one more term you have to write. In place of n, just n plus 1. So 2a square into 4a square into 6 square up to 2n plus 2a square and one more term 2n plus 4 term, because 2 are increasing 2, 4, 6, so 2n plus 2 plus 2, 4. Here 3 square, 5 square, 7 square and so on. Here what? 2n plus 3 square into 2n plus 5 square. So this is un plus 1. Now one by one we have to test. Here just see, main thing is what? Nth term, writing nth term. Clear? So first term can get by using two terms. That's why n equals to 1, then 4. So two terms. N equals to 2, then 6, 3 terms. So 2 terms, 3 terms, 4 terms, and so on. So an term is this. Here. Now we see that ratio test. This is multiplication. So using ratio test we can get the ratio. Now we see that un upon un plus 1. Un upon un plus 1. Okay, un upon un plus 1. What may be the value? Because this upon this means this divided by this. This upon this. Now we see that un upon un plus 1. This upon this. This portion are same. So cancel out. This is in denominator. So we can write what? 2n plus 5 square upon 2n plus 4 square. Clear? 2n plus 4 square. Okay. Now see here. Just un plus 1, ratio test, Raabe's test, Gauss test, and then if Raabe's test fail, then we will use Gauss test. Here, this and this can be written also what? Taking 2n common. Then we get what? 2n square common. Cancel out. 1 plus 5 by 2n. 1 plus 5 by 2n square upon 1 plus 4 by 2n means 2 by n square. Just 2n common. Take common. Then this. Can we get 4 by 2n? 2 by n square. Now this limit is 1. Very simple. Just you can see here. Implies limit n tending to infinity un upon un plus 1 equals to limit n tending to infinity 1 plus 5 by n 2n square upon 1 plus 2 by n square equals to 1. This limit 1. Limit of this is 1 because 0, 0, so 1. This limit is 1, that means ratio test fail. Ratio test fail. Clear? Now try to find limit for Raabe's test. Let us use Raabe's test. For that, we have what? Un upon un plus 1. For Raabe's test, just this minus 1 into n. So this is what? This is the value. Okay, now for Raabe's test, just we have to subtract 1 from here. That's why just we are breaking this square. So here 2n plus 5 square upon 2n plus 4 square. Clear? So just break it. 4n square plus a plus b whole square. So 4 20n plus 25 upon 4n square plus 16n plus 16. Okay, 20 by 16. Clear? This. Now, polynomial upon polynomial. Clear? So from here, we can find the value of n into the quantity for Raabe's test. What? Un upon un plus 1 minus 1 and into n. That is n into this 4n square plus 20n plus 25 upon 4n square plus 16n plus 16 equals minus 1. So n, this minus 1. So this upon this minus 1 means this minus this here. So 4 and 4 and cancel. 20n minus 16n. What? After solving, what we will get? 4 and 4 and cancel here. Denominator will be this. And 4n cancel. 20 minus 60 minus 1. So 4n minus 9. 4n plus 9. So 4n plus 9. N 4n plus 9. Because 25 minus 16. 9. 20 minus 16. 4. So 4n plus 9. Upon this. 4n square plus 16n plus 16. Just we get like this. Clear? For Raabe's test. Ratio test failed, so we are trying for Raabe's test. Now, after this line, just our target is what? Finding limit n tending to infinity, n un upon un plus 1 minus 1. Limit of this quantity. Okay. Limit of this. Limit of n tending to infinity of right hand. This. So 4n square plus 9n upon, just multiply by this n, 4n square plus 9n upon 4n square plus 16n plus 16. Clear? Its limit will be what? 1. Because we can write limit n tending to infinity, just taking common 4n square. So 4n square common, so 1 plus 9 by 4 n. Because 4n square means 4 cancel, n square means 1n cancel, 9n, 4 by 9n. 9 by 4n. And here 1 plus 4 common, so 4 by n, and here 4 by n square, because 4n square is common, so 4 for 16 n square cancel, 4 for 16 n cancel, So 16n. Here 4n square. So this. And this is 0, 0, 0. So this is equals to what? 1. Okay. Raabe's test fail. Raabe's test fail. This is the condition for Raabe's test fail. Now let us try. Gauss test. Gauss test. Okay. Limit 1. Raabe's test fail. Let us try Gauss test. For Gauss test, what we are doing? For Gauss test, just we are trying to writing un upon un plus 1 is equals to alpha plus beta by n plus gamma by n square, alpha greater than 0. Just in this format, we are trying to write un by un plus 1 in this format. Clear? For Gauss test, because Raabe's test is failed. So here, un by un plus 1, we are having like this. Okay? Now, let us try this. And for this, we have what? Un upon un plus 1 equals to this. Un upon un plus 1 equal to this. 2n plus 5 square upon 2n plus 4 square. Just we are having this. Now we are trying to writing in this format. Clear? So let us try to write in this format. Binomial theorem here we will also use. Just we know the formula, because there a square is there, na? Square is there. So we can write it as just 2n common. So what? 1 plus 5 by 2n square upon 1 plus 2 by n square, this is equals to what? 1 plus 5 by 2n square, 1 plus 2 by n minus 2. We can write like this, because we are trying to express as a series, and just write alpha plus beta by n plus gamma by n square. Clear? So here, just see. The un upon un plus 1 equals to, this is equals to 1 plus 5 by 2n. 1 plus 5 by 2n, just we are writing this a plus b whole square, breaking. Just write in the terms of as a series. So what? A plus b whole square, 1 plus 5 by 2 n into 2. So 5 by n plus 25 by 4n square. This is a plus b whole square. And now, binomial theorem we know. 1 plus ax power a minus 2. What? This series can be written as here plus, here minus. So plus minus plus minus plus minus, and x to the power 0, 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. That means what? Like this. 1 minus 2x plus 3x square plus 4 minus 4x cube plus and so on. This is the format. 1, 2, 3, 4, 5, 6, 1 and plus minus plus minus plus minus x to the power 0, 1, 2, 3, 4 and so on. This is a since. This is formula. We know by using binomial series. So you can write here in place of x 2 by n. So 1 minus 2x, x means 2 by n. So 4 by n. We can write 2x, x means what? 2 by n. So 2 into 2 by n, 4 by n, plus 3, x square, that is 2 by n square. 2 by n square means 2 square means 4. 4 into 3, 12. 12 n square. 3 into 4, 12 n square. Minus what? 4 into x cube. 2 power 3, 8 into 4. What? 32 upon n cube, and so on. Now, by multiplying this, we can write, you can adjust it. So 1 into this, 5 by n into this, just write it. First term will be what? 1. Clear? So 1 into 1, 1 will be there. Now, you can do in rough work and write here value. So what will be the value? 1 into 1, 1. Now 1 into minus 4 by n. When 5 by n multiplied to here, so 5 by n minus 4 by n. 5 by n minus 4 by n. So what? 1 by n. So plus 1 by n. Plus 1 by n. Plus 1 by n. Okay. And next term you can write minus 1 into this 12 by n square, and when this into this by n square, and also when this into this n square. So this 3 term can be collected and can be adjusted like this. What? Minus 7 by n square. You can write minus 7 by n square. Clear? Minus 7 by n square, and infinitely you can write terms. So this total will contain value 7. That means we are writing in this format. What format? Alpha plus beta by n square plus gamma by n and here n square. So here we are getting n square. So alpha 1, beta 1, and here plus 1 by n square and minus 7 into, because 1 by n square here, so higher terms will also contain 1 by n square. So 1 by n square you can take common. So you can write in which format? 1 plus 1 by n plus 1 by n square gamma. Because minus 7 into all terms will contain denominator as n. Denominator. So this is gamma. So alpha 1, beta 1, gamma may be anything. Because Gauss test statement what? You have to write like this in this format, where alpha should greater than 0. So alpha equals to 1 greater than 0. Now beta, gamma may be anything. Now beta, here 1 we can write. Now gamma is this. So what is the condition? Statement of Gauss statement. If alpha equals to 1 and beta is less than equal 1, then divergent. If alpha 1 and beta less than equal 1, then divergent. Beta less than equal 1, then divergent. And if alpha 1 and beta greater than 1, then convergent. But here beta less than equal 1. So here beta is equal to 1. Okay. So just write here we see that un upon un plus 1 equals to alpha plus beta upon n plus gamma upon n square, where alpha equals to 1, beta equals to 1. Alpha equals to 1, beta equals to 1, gamma be any value. And gamma may be any value. Clear? So by Gauss test, series is divergent. So by Gauss test, this is divergent. Divergent. Because alpha equals to 1, beta equals to 1. So by Gauss test, series is divergent. Ratio test fail, reverse test fail, Gauss test. In the Gauss test, we are writing in this format, in this series. Okay, so here we see that un by un plus 1 is equals to this format. Here alpha 1, beta 1, gamma may be any value. So we can write like this. So by Gauss test, series is divergent. Clear? So using Gauss test, you can also determine whether the given series is convergent or divergent. If ratio test fail, reverse test fail, then you can use Gauss test. Now remaining two tests are there. So first of all, we are giving it the statement. Just note down a statement, and question you can solve by using this test. Similar, in the similar way, just find ratio and then use starting from ratio test and then reverse test or logarithmic test, and if they are fail also, then you can use what? Further test. Gauss test fail, and in this case here two tests are there, that is De Morgan test, De Morgan's and Bertrand test. Okay, so next test, De Morgan and Bertrand's, Morgan's and Bertrand's test. After this test, De Morgan's and Bertrand test. If ratio test fail, reverse test fail, then you can use either Gauss test or also can use this test. Here, if for series un we get limit n tending to infinitive un upon un plus 1 minus 1 into n minus 1 into log n. Just we are finding this. Okay, so un by un plus 1 minus 1 into n minus 1 n un, just like n un by un plus 1 minus 1 into n. This is for Only just we know this un upon un plus 1 for ratio test, and for Raabe's test we are finding this. Only this is finding for ratio test. This is finding for Raabe's test. And now again, just if ratio test fail, Raabe's test fail, then again you can use this test. Just subtract here from here. Just un upon un plus 1 minus 1. This is the value minus 1. Subtract. First of all, ratio test. Subtract 1 and multiply by n. And if this is also fail, this is ratio, this is Raabe's, this is this. De Morgan and Bertrand test. What? Again subtract from here minus 1 and then into log n. This total. Find this limit. If this limit 1, that is tending to 1, fail. If tending to 1, fail. Then you can use this. And rule is set. Tending to k greater than 1, convergent, less than 1, divergent. Clear? So see, what is the statement? If we are getting this, limit of this is greater than 1, we get this, then just suppose this is k, for this we get this, then un is convergent for k greater than 1, divergent for k less than 1. Clear? This is what method? De Morgan's and Bertrand test. After Raabe's test, you can use also this. Just this minus 1 into log n. Clear? This is De Morgan's and Bertrand test. Okay. So remember this statement. After Raabe's test, just minus 1 and into log n. Then find limit. If limit greater than 1, convergent, less than 1, divergent. And next test is Cauchy's condensation test. Also one test is also there. For this Bertrand test, I will give a questions for your practice. Just you have to do that question. Okay. So here Cauchy's condensation test is also there. Cauchy's condensation test. Statement. Just remember the statement. Okay. What is the statement? If phi n, function of n, is positive, phi n is positive, and phi n is positive for all positive integers, for all n, for all positive integral values. If phi n is positive for all n is positive integral values, and continually decrease this as increases. Means phi n is a function of n where n is positive integer. This phi n continually decrease as n increase. It is decreasing function for as n increase. Then and a and a is greater than 1, positive a is greater than a positive integer. Just you can write like also in this format a, and a is a positive integer greater than 1. Then there are three things are there. Phi n positive, decreasing, a greater than 1, positive integer. Then both the series, then both, or you can write two series, then two series, then two series. First series is phi and second series is this and a power n phi a power n. Phi summation phi n and summation a power n phi a power n are summation a to the power n phi a to the power n, summation phi n and summation a to the power n phi a n, both two series. Means this condition is satisfied. Then if we make a series like this and this, then two series this and this are either convergent or divergent. Either convergent or divergent. That means what? If we are having this type of condition, this is phi n, function of n, which is decreasing function, positive decreasing, and a is positive integer greater than 1, and we make two series, then both series are either convergent or divergent. So here this will be the helping series. If this is convergent, then this is convergent. If this is divergent, this is divergent. Clear? So this is Cauchy's condensation test. By using this, you can solve questions. Make the, because this is given series, suppose. Just by this series, from this series, we can make a series, just taking a positive number greater than 1. If this is decreasing, then if we can determine the convergence or divergence of this series easily, then we can say that this is also convergent or divergent according as this convergent or divergent. So this is Cauchy's condensation test. So for this test you can solve questions also. Just I will give in practice questions for one questions for this test. Okay. So remember this test, all the tests, basic test, ratio test, comparison test, and first ratio and then Raabe's, then logarithmic, then Gauss test, then Bertrand test, De Morgan and Bertrand test, and then Cauchy's condensation test. You can use as we require for testing. Okay. Now I will give some questions for your practice. Just do it in your copy. Okay. So one by one write questions. So question for practice, test for convergence. Test for convergence. Test for convergence. The following. Test for convergence. The following series. Just you have to do it, okay, one by one. First question. Series is root n by root n square plus 1, root n upon root n square plus 1, x to the power n. Okay, here x greater than 0, x greater than 0. This is first question. Clear? Now second question. Test convergence, the series is like this. Second question, x upon 1 into 2 series, x upon 1 into 2 plus x square upon 3 into 4, x square upon 3 into 4 plus x cube upon 5 into 6, x cube upon 5 into 6. Okay, x cube into 5 into 6. 1, 2, 3, 4, 5, 6. X square, x cube, x square, x cube, and so on. Third question. X by 1 plus 1 by 2 x cube by 3, 1 by 2 x cube by 3 plus 1 by 2 3 by 4, 1 into 3, 2 into 4, 1 3 2 4 x power 5 by 5, x power 5 by 5 plus 1 into 3 into 5 upon 2 into 4 into 6 x power 7 by 7 plus and x greater than 0. X greater than 0. This. Just you have to test it. Use ratio test after writing error term. For x square by 2 log 2, x square by 2 log 2, x cube by 3 log 3, log 3, x power 4 by 4 log 4, 2 log 2, 3 log 3, 4 log 4, x square x cube, x4. Clear? Now 5. One plus x by 2, 1 plus x by 2, 2 factorial by 3 square, 2 factorial by 3 square, 2 factorial by 3 square, x square, 3 factorial by 4 cube, 3 factorial by 4 cube, x cube, 4 factorial by 5 power 4, 4 factorial by 5 power 4, x power 4, x greater than 0. Clear? So here 3 square 4 cube 5 power 4, 2 factorial 3 factorial 4 factorial, x square x cube x4, x square x cube x4, x by 2 1. Okay. So this. Now 6. Question 6 is one power p plus 1 by 2 power p plus 1 3 2 4, 1 into 3, 2 into 4 into power p plus 1 3 5 2 4 6, 1 3 5 2 4 6 power p and so on. Okay, this is for Bertrand test. This is for Bertrand test. Okay, you have to test it. Now 7. Question 7. Show that summation 1 plus 1 upon 2 log 2, 1 upon 2 log 2 power p plus 1 upon 3 log 3 power p plus 1 upon 4 log 4 power p infinity. Clear? 2 log 2, 3 log 3, 4 log 4, log 2 power p, log 3 power p, log 4 power p, 3 log 3 power p, this 4 log 4, 3 log 3 power p, 1 by 1 by 1 by and so on. So that this is convergent. This is convergent if p greater than 1, divergent and divergent if p less than equal 1. This is by Cauchy's condensation test you can prove it. By using Cauchy's condensation test. This is Bertrand test. De Morgan and Bertrand test. This is Cauchy's condensation test. By using Cauchy's condensation test, you can prove it. And by using Bertrand test, this is what? De Morgan and Bertrand test. Use this here. This is Cauchy's condensation test. Use this. Okay. And these can be solved by using ratio test, reverse test, logarithmic test, and etc. So these are the questions for your practice, and 1 or 2 questions are also note down for your practice. That is question test for convergence 8. Question 8. Summation n factorial square upon n factorial square upon 2n factorial x to the power n 2n x to the power 2n. And question 9 is one plus 2 factorial by 2 square, 1 plus 2 factorial by 2 square plus 3 factorial by 3 cube, 4 factorial by 4 power 4, 4 factorial by 4 power 4, and so on. So these are the 9 questions. Just you have to solve it in your copy by using any of the test: ratio test, reverse test, logarithmic test, Gauss test, and Bertrand test, condensation test, ratio test, reverse test. You can use. Just solve this 9 questions. Okay. So try to solve and do practice for some more questions. Okay.